Hello guys, this recording is for week 7, Monday. Let me real quick go over the week first. Um, so if you guys have already checked Google Classroom, I have already put up, the work for the week. Monday, you guys are going to be working with vectors, which I'm going to go over in this video. And then Tuesday through Friday is going to be another video on complex numbers, which is like the I square, those kind of stuff. Okay, so I'm going to go back to 6.3 vectors. I pre-wrote some of these again so I can fill in the blank. Saves me a lot of time you know, to teach. So vector is characterized by its two things, which is magnitude, okay, and direction. So usually a vector is drawn as an arrow, which is what you see at the bottom. So all of these at the bottom, all of these right here, these are all vectors. Okay, and then I'll explain how you draw them. So let's talk about the length first. The length of the arrow is the magnitude. So anytime if I ask for, oh, what is the magnitude of this length right here, or this, vector right here, then you would basically use the distance formula and figure out what the length is. And then the second thing is the direction. Where is this arrow pointing at? Is really important. So direction of the arrowhead. And it indicates the direction of the vector. Okay. And then the last point is two vectors are equal if and only if they are the same magnitude and the same direction. Okay, so let's look at these ones down here real quick. Out of all of them, which ones are the same, are equal? It would be the u and the other u. So vector u and vector u, they put it the same thing, same label because they're equal. Even though they are positions differently, like one is up here and the other one is over here, they are still equal. Okay, so how come vector u and vector w are different? Or actually, I'm gonna put it like that. Why are they not equal? They are pointing to the same direction, but they have different length. Okay, it's pretty obviously that they're a different length. So same direction, but different magnitudes. Okay, last one. How come vector u is not equal to vector v? And also pretty obvious, this one would be same magnitude, but different directions. Okie dokie. So let's move on and kind of do some math from here. Um, so magnitude and directions of a vector. Let's talk about how we look for these. If the endpoint of u has polar coordinates r comma theta, so if you don't know what polar is, go back to my previous lesson and look at how we find polar. The endpoint, which is right here, okay, even though we have an arrow represents a direction, but it doesn't mean that it's going to keep going. Okay, so that point right there is considered as r comma theta. Then the magnitude is of u is really absolute value of u equals to r. Okay, this length right here can also be called u, and it's really also r. Okay, and the direction of u is determined by theta. Theta. Okay, it goes from your horizontal positive axis to the length that you want. Okay, so that angle right there is considered as the direction. And let's write down computing the magnitude and direction of the vector. If I say u equals to a comma b, then absolute value of u would equal to, from the last section, the way that we found r was we found the square roots of a squared plus b squared. I think last section we used x and y, so it's really the same thing. If these were x and y, we can still use a and b. Okay, so square root of a squared plus b squared. And this is how we found magnitude. Okay, now for direction. Direction is theta. So the way that we found theta from last section, we would have to use, remember it was like this. So if this one is A here, B here, how do I find this angle? We have to use tangent. Tangent theta equals to B over A. Then theta would be inverse tangent of B over A. Okay. So let's try to do an example. Find the magnitude of the vector negative 3, comma 2. And then we're also going to find the, find the magnitude and the direction. Okay, so let's follow the formula above and to find our magnitude. Magnitude, our formula was absolute value of u equal to square root of a squared plus b squared. So really just put the numbers in the a and in b. And we take the square root of that. We get square root of 13. You can leave it like this, or you can put it in the calculator, and we find that it's approximately 3.6. Okay, and then for the direction, it would be theta equals inverse tangent of b over 8, right? So if I rewrite it again, it would be 2 over negative 3 inside the inverse tangent, which equal, so these questions right here, since we are dealing with pi or dealing with radian, you want to put this in radian form, and it would be negative 0.59. Okay, that's what you get from the calculator. But here's the thing. If I were to draw this out, negative 3, comma 2, it's up here, right? So that means my arrow is pointing this way. Okay? And in terms of the 2 pi, pi, and stuff, like in terms of my coordinate plane, my unit circle, this is 0, this is pi, and pi is 3.14, right? And then we ended at 6.28. And halfway is, I don't know, what's half of 3.14? I don't have a calculator with me. So my answer right here, negative 0.59. I am technically going backward, and it's right here. the answer that I just circled, it's actually the arrow that's pointing the opposite way. So how do I get my answer to be back on this arrow right here? I would have to add this amount, which is pi. If you add half of the circle to this answer, then you'll get back to negative 3 comma 2. Okay, so our final answer is really negative 0.59 plus pi. That's how we find our direction. Okay, let's move on. So the next part we're going to do is vector addition and vector subtraction. We split it in half. Vectors addition, it's pretty straightforward. If I have a vector u equals to a comma b and a v equals to c comma d, then u plus v, whenever I want to add two vectors together, you're just adding the first plus first and last and last. Okay, so a plus c comma b plus d. This is the computation way. If you're going to draw this out, it's very easy too. So if I have, let's say, let's pretend if my u is pointing up like this. This is u. Okay? And this one is v. Okay? To find out my, wait, hold on. Yeah, my final answer, I would have to redraw this v. Let me put in another color. Let's put it in red. Let's say this is v, that's u. I would have to redraw my v to connect the end of u. Okay, so I would have to redraw it up here. It's exactly the same length as v. Okay, and then my final answer would be from the beginning point to the end of v. So this green line right here is u plus v. Okay, let me do another example. If I have a length that's yeah, that's pointing up here, this is u, and I have a length that's pointing down here, that's v. Okay, to finalize, to figure out what is u plus v, I would have to redraw my v to be at the end of u, which is starting right here. And you just redraw that. Hold on. Are they kind of the same? No. Okay, almost. So I redraw my v to be placed at the arrow of u, and then u plus v would be from the beginning of u to the arrow of v. That would be u plus v. Okay, so that's vector addition. Now vector subtraction is if u equals to a comma b and v equals to c comma d, then u minus v would be subtracting each of them, a minus c and b minus d. Okay, so let's also draw that. This one is actually easier than the vector addition, drawing wise. if I have a u, oops, u going up here and a v going this way, okay, your final answer, which I used green earlier, your final answer to find u minus v would be going from the end of v, which is the arrow of v, to the arrow of u. Okay, that would be u minus v. Let's do another one. If I have u going this way, okay, and then my v going this way. Oops, that's not v, I use purple. So if this is v, this is u. To do u minus v, again, start at the arrow of v to the arrow of u. So I go from v to u. That would be u minus v. Okay. So let's do some example. If I have, so given u equals to 1 comma 2 and v equals 3 comma 1. What would be u plus v and what would be u minus v? Let's do the computation way and then we'll draw it out as well. So computation y, we're going to be adding our 1 plus 3 and then our 2 plus 1. Because we got to add these two first and then we'll add the last ones. Okay, so add them together, then we'll get 4 comma 3 in parentheses. Let's draw it out. 1 comma 2, 1 up 2 is right here. And then 3, 1 is right here. Okay, so if this was u, this was v, we gotta redraw v to bring it to the end of u, which would be right here. And then I gotta connect the points from the beginning of u to v. U plus v. That would be the picture. Okay, how about u minus v? U minus v, I gotta subtract the first number, then subtract the last number. And remember, there is a order because you have to start with u first and then go to v. So your final answer here would be negative 2 comma 1. Let's draw it out. 1 up 2, again, is right here. 3, 1. This is v, this is u. Okay, our final answer here is go from the last one to u. So u minus v looks like this. Okay, so if you feel like you got the hang of it, then you don't have to look at my next example, but I'm gonna do one more. Let me see, this is u and this is v. Wait, did I already go through that one? Nope, this is a new one. Yeah. Okay, so let's do a u plus v and a u minus v. U plus v, you can pause the video and do it on your own if you want. I'm going to write my answer now. It's going to be negative 7 and negative 1. This is u plus v. U minus v, would be -1 and 3. And then picture-wise, would be 1, 2, 3, 4, up 1. -4, up 1. This is U. And V would be -3, down 2. This is V. Okay, so I'm going to redraw V right here. And we're going to connect the points from the beginning of U to V. This would be U plus V. And then for U minus V, we have 1, 2, 3, 4, up 1. -3, down 2. This is U, this is V, and we can just keep it like this. And our final answer of U minus V would be going from V to U. Is U minus V. All right. So our next, the next part would be scalar multiplication. So after we learn adding and subtracting, there's also multiplication, but there's two parts to this multiplication. The first part is called scalar multiplication, and it's just exactly like distributive property. Okay, so if you have a factor, which is U equals to A comma B, and you have a number T, which is a real number, which means like, any number. It's a real number. And if I ever put T times U, which we're really going to do T times A comma B. That's the same thing as saying T times A and T times B. Let's just do a quick example. If I have U equals to 2 comma 1, and I want to compute 2U and -2U, then I'm really just going to take my 2 times 2 comma 1, which is 4 comma 2, and I take my -2 times 2 comma 1, which is -4 comma -2. And this would be 2U and -2U. Okay, that's only if you have a number, just a regular number times a factor. Then you just kind of distribute it in. Okay, so there's a second part to this multiplication, which is called the dot product. Okay, and I promise this would be the last part of the section. So the dot product usually is represented by a U times V, or a factor times another factor. So please look below for this formula. Suppose we have a U equals to A times B. Highlight this. Okay, and we have U comma B, and we have a V equals to C comma D. Whenever you want to multiply your two factors together, it actually just turns into one number. And what that means is that we're going to multiply our first times first, which is A times C, and we're going to add our last times last, B times D. And it will actually turn into a number because we're not doing any commas. We're trying to combine it together after we multiply it. So let's look at an example. Suppose U equals 2 times 2 comma 3, and V equals 5 comma 4. And we want to do u times v. So how would we do u times v in this case? Follow the formula above. We're going to times the first times first, which is 2 times 2 times 5. We're going to add 3 times 4, which we get 10 plus 12. So we get 22. Okay, one more example. So suppose u equals negative 3 comma 2 and v equals 4 comma 5. So what would be u times v? We multiply first times first, which we get negative 3 times 4, and we're going to add 2 times 5, which is negative 12 plus 10, which is negative 2. Okay, we still have to take into account with those negatives if you ever have any, and it's just, multiplying the same way that we do in algebra. Okay, so that's it for Monday vector. You're going to be doing 2 through 16 even, but you can skip number 12, but all your questions are on the first 2 pages. Okay, let me know if you have any questions. That's it.